Alright guys, so don't mind the extra writing down the bottom, that's just the marking scheme, and this is the actual question. A particle P traveling a straight line has a deceleration, right? So deceleration means A equals minus 4 v n plus 1. Choice is what to do with A. Do we use the v dt or phi times the v dx? So you have a choice between phi times the v dx and the v dt. Well, the answer says in terms of t, so that answers that for us. We're going to use the v dt. Okay, we're going to cross multiply. I'll probably end up doing this slightly different. All right, so I'm gonna do minus 4 to t on the right hand side. On the left hand side, I'm going to have 1 over Vn plus 1 to v. I'll use the negative power rule. The negative power rule would be minus 1 over Vn minus 1 equals minus 4 to t. We're going to integrate it in the same way we'd integrate phi to the power minus 3. You add 1 onto the power, divide by the new power. Is that okay? Now, what are your limits? Well, t and 0. You start off at speed u, so that would be v and u on this side. Okay, I'll just get rid of this for a second. It's really not necessary anyway. Just drag it over there. Now, what we're going to get next is when we integrate this, what do we get? Anybody tell me? Add 1 onto the power. V to the power minus n. And what's underneath? So there's a v there as well. All over minus n. And that is from phi du. And this is going to be minus 4t from t to 0. Okay. Next part, sub in v and u. Okay. So let's just drag this away. Now, next part is to sub in. Ever kill this? So it's going to be v to the power minus n all over minus n minus u to the power minus n over minus n, and then you sub in, you get minus 4t, and it's just take away 0, isn't it? Alright, and what does it want? It wants phi on its own, so phi is the one we want to get on its own. Is that alright? So, how about, we have a common denominator of minus n, don't we? So what can I do with that minus n? I can multiply it by the minus 4t. It's equivalent to doing this. So did everybody agree with 4nt on this side? Then we get phi minus n, u minus n, alright? So next thing I'm going to do is bring over the un. It isn't specific about the presentation, is it? It just wants phi on its own, right? Now, what is phi to the power minus n? What is it? It's 1 over. Everybody agrees 1 over Vn. What happens if I flip both sides? What will happen then? What'd you say? I'm going to keep it like that. Did you get a common denominator with un?
No, the using the mindset being just the un on top. It's the same as the v.
It's part of a fraction though, so I can't separate them. No. So look, if you want me to do that, here's what I can do here. I could use that, what I have there, But if you really want me to be correct about it, it's, according to the question, it's not necessary. I don't have to put in any specific form, but anyways, I could do that. Then get a common denominator. Just lob a u to the power n at the back here. And then have it all over one denominator, which is the un. And then when I flip it upside down, the un will be on top. Can't do that otherwise. Okay? So that's un over, is that the way the American scheme presents it, is it?
No, they just did, because it was 1 over u and they just put the u on the top.
Right. Now, alright, if that was phi squared, what would you do? You'd square root both sides, wouldn't you? So what can you do with phi n? You can do the nth root if you want, or you can do 1 over n, your call. So phi equals the u to the power of n all over 4nt plus 1 over n. Is that cool, you guys? Now I wonder what way I'm just going to see what way the marking scheme laid that out for us. I have it over here somewhere. Not you. Is it you? That's part B. Yeah, it does what I think it does there, yeah. We can do that now. Oh, actually, I forgot my u to the n, didn't I? There's a un here. Forgot all about it. Now, here's what they do at the very end. They break up the the powers. So what's u to the n by 1 over n? Plus u. So that's the way, and I keep forgetting the un in here. There's a u to the power of n plus 1 there as well. Yes? Yeah, of course. If you got that on a test, you'd almost think you're wrong, wouldn't you? It's that complicated looking. But yeah, that's what we have there. Alright, next one. When n equals 3, obtain an expression for the speed of p when it has travelled a distance of 3. There's a hint there, isn't there? Velocity in terms of velocity and distance. Phi equals ds dt, because that's handy, and we already have a value for phi, don't we? Okay, would there be any, what would happen if you used phi times the v dx? Would that also work? Did anybody do phi times the v dx? Did it work? Worked just as good, did it? We can go for that. Alright, might show you two methods here, okay? That's cool with you guys? So phi times the v dx will take you right back to the start, will it? Yeah. So just because you don't agree with the marking scheme doesn't mean it can't be done. So s can also be written as x, can't it? Same thing. So phi times the v dx. Okay, and we're going to maneuver this around again. So what happens if I cancel v off both sides? What would that do? What's phi to the power of n plus 1? Phi to the power of n, phi to the power of 1, right? What happens if I cancel phi off both sides? What's left? Phi to the power of n. Bring the phi n underneath. You get 1 over phi n dv equals minus 4 plus dx, isn't it? In fact, this is a lot easier than the last part. You could do question 2 without having done question 1 at all, isn't that right? So does everyone understand that? You actually have access to part 2 while completely messing up part 1. Just be aware of that. Okay? Now, just going to get rid of all this. That was so difficult in comparison. Alright, we're going to use the negative power rule and then we're going to integrate. Okay? So we're going to use the negative power rule, then we're going to integrate. So we'll change that to v to the power minus n. And then after that's v to the power minus n, we're going to say no bother. Yes?
Why can't you just turn it into like
Huh?
If you were integrating still the practical, wouldn't you just do ln v2?
Oh, ln's only used for when it's power of 1. And the reason why ln is used is because when you take away 1 from the power, it comes power of 0, and you can't divide by 0. That's the only reason we ever use ln. It has to be the variable to the power of 1 on the bottom, or the variable to the power of minus 1. This is not that case, it's the power of n. So that means we don't have to worry about that. So I add 1 onto the power, what do I get? 1 minus n. And then that's phi to the power of 1 minus n. Oh, sorry, I forgot to put up my integration signs. Alright, what are our limits? It just says obtain an expression. It doesn't say what letters I have to use, does it? That's odd. But we know when x is 0, the speed is? Yep. Which makes sense. And we know that it's looking for when we're at distance of 3. So that'll be v. Imprecise. It doesn't tell us what letters I'm allowed to use or not allowed to use. So I think there's lots of free reign here in a way. So, alright. Now, let's do v minus u here. V and u. And this is 4t from 3 to 0. That obviously makes that minus 12. Okay, let's throw in the u values. So it's going to be, okay, it's going to be phi to the power of 1 minus n all over 1 minus n. Then it's going to be u to the power of 1 minus n all over 1 minus n. I'm going to give it a common denominator of 1 minus n. Is that okay?
Well, you have n equals 3.
Oh, do I have n equals 3? Yeah. Brilliant. Alright. Well, that makes my life a lot easier. So, even then, common denominator. Alright? And I'm just going to put in n equals 3. Is that okay? So I haven't yet made a mistake. I just haven't used all the information available to me. So what happens when n equals 3? So phi to the power of minus 2, u to the power of minus 2, and up here? Plus 24. Now, to be honest, at the very beginning of the question, you could have just had that as phi to the minus 3, and that would have made things a lot easier. You would have, when you integrated that, you would have got phi minus 2 over minus 2, yeah. And you'd integrate that from phi to u, and you'd end up at the exact same spot. Okay, so that's all good. Now, yeah, so isolate phi on its own, yeah? So to isolate phi on its own, what we'll do is we'll convert them both into fractions. 1 over v squared minus 1 over u squared equals 24. 1 over phi squared equals 24 minus 1 over u squared. Now, what do you think I'm going to do there? I'm going to give that a u squared top and bottom. Anybody know why? What can I do next then? Huh? I can turn it upside down. Flip it upside down. And what I'll get is phi squared equals u squared over 24 u squared take away 1. Square root both sides. Square root u squared, you just get u. And then you just get the square root of... Oh, I've gotten a different answer to the scheme. So is there a mistake there with the minus 1?
Yeah, you didn't.
Oh, tell me these things. What did I do? Oh, it was a minus 1 on that. So it's a plus 1 there. My bad. Square root at the top is u. And I don't mind being corrected, lads. Just if you see a mistake, just let me know. We kill with that? Yeah.
Do you have to
there's nothing to say you have to. So you wouldn't know, would you? I know from myself and most marketing schemes they generally get rid of easy negative powers. So, but there's nothing that in that marketing scheme to say I have to deduct from you, because it doesn't say fit a certain form. Now, the other way of doing this would have been, actually no, they used the method we used. Yeah, they didn't use the STT at all. Never mind. Same answer, isn't it? Grant. All good. Right, let's move on to the next one. Do you want me to do part